Alright, good morning. I've been quite looking forward to today's lesson because today we're going to go through and wrap up the types of processor topic, go through the feedback from the cover sheet, and then introduce two things to wrap up this topic. So first of all, the big thing is the difference between CISC and RISC. So to summarize this, let's have a look at Chat GPT. So is it just that? I don't know. Here we go. Yeah, this was released last week, and I think it's phenomenal. It's currently free, and then you'll have to pay for it. But at the moment, you should be able to use it for free. You might have to sign in with a Microsoft account. So let's just sign in. It has to be a personal Microsoft account. I'm afraid your school one won't work. That's frustrating. So you might just have to watch this if you don't have a personal one. But an Xbox account at home will work. That'll be fine. Here we go. So, what is the difference between CISC and RISC? What's going on here? So this is a natural language model, an AI, machine learning, which is designed to understand natural language, research pretty much anything that's out there on the internet, and format it back to you. And as a revision tool, it's phenomenal. It doesn't always get it right, but it does a pretty good job. So for example, define all the keywords relevant to RISC versus CISC. If you missed any keywords, get AI to do the hard work for you. Look at that. Come on, you should be defining CISC as well, please. Oh, there we go. But it's not just the ones I asked for. It spots that there are some other things that are rather useful too. That's nice, isn't it? It's phenomenal. And what about if we want to test ourselves this morning? Let's be polite to our AI because one day it'll take over the world. Please generate 10 multiple... No, let's go for 5 because we haven't got all day. Multiple choice questions on... Well, what's the actual topic called? Types of processor. Types of processor suitable for OCR A level. Look at that! How clever is that? My job... Oh, you don't need me anymore. But it doesn't tell us the answers. That's rather nice, isn't it? It will do when I ask it to, but for now, it's not going to. So you can discuss with the people next to you. I'll leave this on your screen. I'll pause the video. See if you can answer all of these things. How good is this as a revision tool? Love it. So this is an example of the homework that we've got. I asked you to write a program, well I gave you a program that would generate all or identify all of the prime numbers between 1 and I think 10 million. And you had to split that program between multiple threads and find out how long it took. I was hoping that you would be able to run the program and record it. Some of you, give me a nod if you ran it multiple times. So you did it like 3 times and took an average. Video. So the next stage would be to analyze this somehow. We've got our threads and our speed, and is a higher speed or a lower speed? Actually, speed is not measured in milliseconds, is it? It's execution time. So if we insert a little graph, we should be able to see. No, I want a relationship one, so something like that. Here we go. So which way round is this? We've got the number of threads along the bottom. So let's maximize add a chart elements, axis title for both of them. Like so. This is execution time in milliseconds. And this is the number of threads. And well done to this person for concentrating most of the research in a small number, but then going bigger. Not doing every number of threads, that would take you ages until we get a reasonable number. So I'm just going to change this for now to focus on up to 10 threads. So we can see that there is an optimum. As you increase the number of threads, and what does that mean? Well, we've got an algorithm that is doing a lot of work. If we try and do it all in one thread, it's just going to limit it to being one CPU core that can do this, because you can't divide it up. As you go to 2 threads, we're saying that the program knows that there's a lot of work here. You can allocate it between 2 cores, or split it between 3 cores or 4 cores. So my guess is that on this physical processor, there'll be a processor with 4 cores on that CPU. So we've established that that's true, and as you have more threads, well, there's no point having... No, that's not strictly true. There's no performance advantage in having more threads if you haven't got enough cores to service them. Think of it like going to Boots, you're getting your meal deal or your makeup or whatever you fancy, and then they say, cashier number 3, please. If they've got 10 booths, is that the right thing? Cashiers, and there's 100 people to be served, then there's still going to be a queue of people waiting. In order to have the performance boost and minimise the execution time, you're going to need 100 cashiers in order to continue this relationship in a linear fashion. Okay. Next thing that I'd like to talk about is to go back to GPT-3, this algorithm here. So let's see. Write a program to identify all of the prime numbers between 1 and 10, 1, 2, 3. I'm going to put the commas in to see if it can cope with it. Which language is it going to think it would need it in? Oh, in Python. Thank you very much. How incredible is this? We know that AI is going to take over the world and free us up from irritating jobs in factories, but did you know it's also going to make some bad programmers redundant? This isn't necessarily good, but usually it's functional. I don't want it in Python. Please translate to C#. It knows what I'm talking about. I don't need to repeat the question. How good is this?
What's this been out for?
I've never tried this before, but please translate to little man computer assembly. Bear in mind that's not a real language, but it does it. That's incredible, isn't it? I mean, I don't know if this is going to be possible, but in theory, that doesn't look like it's going to work. I'd be very, very surprised if that works.
It clearly knows something you don't.
Yeah, that won't work.
What if we ask it to do something illegal?
Okay, so we've established that this is valid syntax, but it is not going to do what we want it to do. Can you translate to a more known language, times 86 assembly? Possibly. This looks better. Now we've actually got an algorithm to check and see if it is prime. So we have different mnemonics in times 86 assembly. Bearing in mind for your A-level, you are not expected to recognise, understand or create any of this. You are expected to recognise, understand and create some of this. But you won't be expected to do a prime number thing, don't worry. And in our next topic, we'll understand how this is generated, the advantages of generating all of this, and how it works, and the role of a compiler. But look how it can explain code. You can give it code and it will explain it. You can give it code and ask it to sabotage it with errors, or you can give it broken code and ask it to debug it. It's phenomenal. Absolutely phenomenal. Let's go back to the C# version, please. Remember your pleases and thank yous. There we go, this is better. Will it be able to adjust it so it can run in multiple threads? I'd be very impressed if it can. Let's see. Please, can you refactor it so the algorithm runs in any number of different threads? Ooh, here we go. Looking promising. We've got the same algorithm to check if a number is prime. Where's the multi-threaded bit? Oh, it's creating a new thread, just like we did before. It's hard coding it to 4, so it's not as flexible as ours. But it works. I like that.
It made a flexible one on mine.
Did it? Oh, nice. So it's giving different answers to different people. Please add a stopwatch to time the total execution time in milliseconds. Will it work? Don't know. Either way, I'm already impressed. Don't sit there and sulk, AI. You can do this. I believe in you. Can't give you a class chats positive, but I will speak very highly of you and maybe even subscribe when this free trial runs out.
How much is it?
So we've had a little chat about plagiarism and everything, but to summarise, let's have a look at this. We've heard that AI will replace manual labour, and now, worryingly, it will replace poor programmers. I say poor programmers because you still need to be able to debug this and spot when it's not working. Can it be creative? Please write a song to help me remember the key facts about RISC versus CISC. I'd like it to rhyme, and ideally I'd like the tune to be Jingle Bells. Too many requests, oh dear. Everyone's making requests at the same time. It's reassuring to know that AI is limited. It's not the actual it's not the actual AI model that's limited. It's probably a quota for everyone on our IP address. That's really sad. Please stop making your requests, everybody. I want to make mine. I want my revision thing. No more requests. Oh. So this is the homework. I gave you this in a version, I think it's Visual Studio 2022, so it might be slightly different. I think there's value in working out how to make it work in school, and there's also value in talking about the limitations in this. So let's have a look. Can we open it in Visual Studio? No, that would be far too nice, wouldn't it? And it's not working today. So let's open Visual Studio. The main difference is they've optimized the new version of C#, and I don't actually like it because it's not platform compatible. If I try and run it on Linux, it doesn't seem to work all that well. I want to check it out from source control. How can I do that? From GitHub. Yeah, here we go. Is that the one? Yeah, that'll work nicely. Sorry, I should have checked it out on the W drive. Not following my own advice. So it's quite likely that this solution will not work for two reasons. The first of which, it uses a different syntax and it hides the boilerplate because it thinks that you're stupid and relying on AI rather than actually understanding everything, which may be true in the future, but it's not true for you. Let's have a look. So how can we fix it? Oh no, I have put like all the boilerplate in, all of this. But when we try and run it, says something doesn't exist, probably because the project isn't set up to be able to compile on here. We need a different framework. We have got old frameworks on here. I think the one that I've got it set up for on GitHub is probably .NET Framework 6, so we need the latest one we've got in school, and we need a startup object. This is going to be the thing that will load when the project starts. So I got to that with project and prime test properties, or your project properties. Now that we've done that, we can save it and hopefully it'll compile. Except that it doesn't. So let's have a look. Could not find primetest.program. So we need to do some debugging. Primetest.program.
When I did it, opened all the programs.
Right, so we had to set up the namespace properly, and we're getting there. It doesn't know what task is, and then we have to put all the imports with Alt-Enter. So I guess the new version of C# is helpful. It puts in some default things here. We can't have a parameter called t because we've already got t up here. Interesting. Oh yeah, gosh, this is a really nasty way of doing things. We could change this excuse me, to something else. So we have task ID here, which is going to kind of break things, and I'll deliberately leave it broken to see what's happening. Yep. And I'd like to put the console.write lines in. Look, it says thread 5 has finished 5 times. This is a really good example of the type of thing that can go wrong in a non-thread safe thing if you're not too sure what's going on about asynchronous programming. Synchronous means one thing followed by the other. Asynchronous means all at once. So you have a synchronous timetable. You have computer science followed by break, followed by something else. If your day was asynchronous, you'd have all your subjects plus break plus lunch at the same time. Asynchronous is better for performance. Sorry, can't talk today. But it's obviously slightly more complicated. So let's see, we're making the threads. Int t is 0 up to the number of threads that we want. And we're using that here, and we're displaying that value, surely, thread t has finished. So why does it say that they're all 5? Well, it's because this, where's the for loop? We'll do all 5 of them to create the threads before the threads are finished. So we need to pass that value in, which we're doing here, and then get that value as a parameter, which is what we're trying to do here, and then we can display the task ID separately. Hopefully this will say task 1, 2, 3, 4, 5. There we go. And they are not in order, which kind of makes sense, doesn't it? Because they all start at the same time. This is a slightly different implementation, I think. So what's next? We wanted to test it with 100,000 threads. So let's just test it with 5 and remember how many there are. I think that's the right number, 617405. This time, with 100,000 threads, oops, I should have disabled this, it might give us the same number because the console.write line is thread safe. It's designed so that only one thread can access the console at once. Otherwise, the console is going to get corrupted, and like you'd write half a line from one thread and half a line from the other thread, and it would be a disaster if it was not thread safe. But look, it's got a mashed up, dodgy number. If we get rid of the console.write line, it should be a little bit faster, but we'll still have the wrong result. Let's just go for 10,000 and hope for the best. There we go. We still haven't got the right number. Why? Well, we talked about this last lesson, but we didn't say how to fix it. We said that we have a shared variable, and the example we used was the whiteboard in my classroom, where we said that if all of you finish a job at a time, and when you finish your job, you come and wipe the whiteboard and put your own value on, that's fine most of the time, but if millions of you all try to do it at the same time, you'll have a fight and you'll conflict with each other and you'll lose the value on the whiteboard. So we need to control access to shared resources. This is not thread safe. That means it's not going to work reliably in a multi-threaded environment. How can we fix it? Well, we have a mutex. We presumably haven't got the using thing properly, so using system.threaded. Threading, there we go. What is a mutex? Well, a mutex is something that is indivisible and can guard resources. As in, a mutex cannot be interrupted by the scheduling algorithm by the operating system. And if something is locked, then no other thread can access it. That's both good and bad. We talked a little bit about that last time. Then, anything that uses our shared resource, which is this bit down here, so thread prime count is a local variable, that can do its own thing, it's not going to interfere with anyone else, but prime count, that was our shared resource shared between all of the threads. This is problematic. This single line of code is being interrupted in between finding its value and increasing its value, which is why it's underreporting the number of prime numbers. So what can we do? Well, we have our mutex, and then we want to lock it. Did I call it M? I can't remember. Yeah, where did it go? Yeah, M. So, is it weight 1? Here we go. So what this is going to do is saying, well, if some other thread has requested access to this mutex, then we need to wait patiently in line. Remember the analogy of the whiteboard behind me? If another student is currently wiping the whiteboard, you don't push them out the way and then put your number, because that's going to interrupt them. You wait patiently, you wait your turn. If I run it now, the whole thing's going to crash, because every thread, let's try it. Even with 5 threads, it'll wait forever, because every thread is attempting to lock that shared resource. It's waiting for that mutex, and it's never going to get access to it, because another thread has requested it. So once you've done what you need to do with the shared resource, you release it. You release the mutex and you say, I'm done with the whiteboard. I'm done with that shared resource. Somebody else can have it. Let's check if it works with 5 threads. It will be slightly slower because there's a bit of overhead of accessing that mutex. But hopefully, if we do 100,000 threads, it will be quite a lot slower than it would have been before, but it should give you the right number of prime numbers. I don't know if that's correct or not. It is a different number to what we had before, but will we get that number reliably? Oh, interesting. No. Well, there we go. All the best examples. Maybe there's another bit of shared resource that isn't working properly. I'm not entirely sure. But at least it explains the concept and the principle. This is well beyond the scope of the A-level. We don't need to know how to do any asynchronous programming. But you do need to be aware of the fact that in order to make the most of a parallel system, you need to have a system that can cope with that, as in a multi-core system with multiple execution units. You need to have the software compiled in a way that makes use of the hardware, and that's why we've done this multi-threaded programming. Going to give you your cover sheets and I'll stop recording for a mo. The big bit of feedback for almost everyone was there was a question about parallel processing, and I don't think anybody talked about these different types of instruction. Lots of you said we use multiple cores. Well, yeah, great, but it's more than that. We can do pipelining to have different stages of the fetch, decode, execute process at the same time, and we can have single instructions on single data. That is not in parallel. SIMD means one instruction performed in parallel on multiple items of data. So maybe it's my fault for just not making it crystal clear that this is parallel processing. On a single computer, you can do multiple things at the same time through these types of instructions. So this was a challenging topic test. There's lots that we can learn from. So question 1 then. A GPU is a type of coprocessor. Not many of us wrote that phrase down. Maybe you need to scribble that in on your keywords. Again, they should be printed 2 per page, double-sided in colour, preferably. What is a coprocessor? It works alongside a computer, so in parallel with the CPU. Not many of us got those 2 points. Why is that good? Because it frees up the CPU to do other stuff. It takes the strain off. It's like having a teacher assistant in a classroom, or OpenAI to do all the thinking for you. What type of strain? Well, it handles stuff that is particularly focused on graphics manipulation. Remember, this is a question specifically about the GPU. Maybe I should get the topic sheet open so that we can see what we're talking about. We'll plop that on here. We'll get that over here. There we go. Question 1. The role of the GPU. Lots of you did get this bullet point. We don't need that to be quite as big. They're specially designed. This bit was what you said. You said they're very good at floating point arithmetic, specialized circuitry, anything to that effect. I think we've kind of got this bullet point already in here. It's just an extra opportunity to get it. It frees up the processor. If you take the strain off the CPU, it means the CPU is free to do other things. Lots of you got 2 marks for this. Not many of you got 4. Why? Well, intensive tasks tend to perform better on CISC rather than RISC. Why? Well, because there are specialist instructions on CISC that aren't available on RISC, like MMX instructions for decoding or encoding JPEG, or like MP4, like built into the instruction set, particular optimizations for intensive tasks. We should be writing this down. Full range of addressing modes. So we didn't explicitly mention that in the topic, but we did in the previous topic. We talked about all of those address modes. Well done. So we just had a recap of those addressing modes. All different ones are available in CISC, but they might not be available in RISC. And there are more addressing modes than the 4 that we've looked at A level. But obviously you only need to know immediate, indexed, direct, and indirect. You might want to recap that if you don't know what I'm talking about. There are more instructions in the instruction set for CISC, which means that your code will take fewer lines in CISC compared to RISC. That means that you're going to use less RAM to store your instructions in RISC because you need fewer instructions to complete your task. And if you think about writing it in C# or Python, that is going to more closely represent the assembler instructions in CISC, because you need fewer CISC instructions to represent a high-level instruction. Remember, high level means high level of abstraction, not high level of skill. We're talking distancing yourself away from the nitty-gritty of what happens in the processor, hiding the unnecessary detail. Disadvantages. The hardware has to be more complex in RISC because you've got more instructions, and each of those instructions needs to be implemented in hardware, which then increases your manufacturing costs. Lots of you got that bullet point. It can take multiple instruction cycles, clock ticks, to execute individual instructions in CISC, whereas RISC is designed deliberately to just take one. So even though CISC takes less memory for RISC, the same number of instructions may well execute faster in RISC because you have pipelining, and also individual instructions are going to take individual clock ticks for RISC. And then CISC has more transistors, so therefore more energy consumption. RISC is also designed for mobile devices, so special functionality to switch off when you're not needing it. Much better to have 16 RISC cores in a mobile device than one super fast, high performance CISC core, because the battery will last much longer if you can switch off the RISC cores that you don't need. Alright, so next question then. This is the one that we lost the most marks on. So write down anything that you didn't get the marks for. Not many of you got this acronym here, but you did talk about individual execution units, multiple execution units. I gave you credit for that. Lots of you did get this one. Each core has its own fetch, decode, execute hardware. And then if you discuss the implication of that, if you've got more cores that can fetch, decode, execute, then that's going to potentially speed things up. Have you defined what parallel processing is? And there's still some confusion between parallel and concurrency. Concurrency is the illusion of parallel processing, because you do one thing, you stop, and then you do another thing, and you do that very, very quickly. Parallel means it's actually happening at the same moment in time. Concurrency, that might not be true. And we'll come back to that when we do operating systems and scheduling. Parallel processing means we're actually doing it at the same time because you've got multiple things that can do it, like a coprocessor or multiple cores or a GPU or something. This is the bit that we've talked about that you didn't include, most of us. So why is this in parallel? Because if you have a single instruction like add, you can not just add one set of values, you can add hundreds of values or 10 values or whatever you want. How is that actually implemented? Well, you will have to have all of the logic gates to be able to do all 10 of them at the same time. It's in parallel. It might not be on separate cores. It might be within the same processor, but you'll have separate logic circuitry to be able to execute it in multiple places. Or it might be on multiple cores. It depends how it's implemented. Each instruction is going to be executed at the same time, and it's particularly helpful for multimedia because you can be decoding multiple pixels at the same time, or encoding into like MP3 audio, anything like that. And then this is just an extension of that. Rather than just a single instruction, you've now got a complex algorithm, multiple instructions on multiple data. These are often called vector instructions. Why? Because a vector is just something that can store multiple values, and a vector is an operation that you can do vector maths, can't you? And instead of just performing that instruction on one value, you do it on multiple values. It's the same idea, but in hardware. If there's anything that hasn't made sense on here, then ask OpenAI, because it's probably far more intelligent than me. And then between now and the end of the lesson, why don't you start Advent of Code? I really like this for, I don't know why it's signed me in as a different account at home to it has at school. I have actually done up to 4, but it hasn't recognised that here. It's really weird. You get some test data. I've been teaching you with CompeteWithCode.uk all about using regular expressions and data structures and validation and all that kind of stuff. Now is your time to use that. Every day in Advent there is a computational challenge, which incidentally, if you copy and paste it into OpenAI and ask for a solution, That's cheating. Don't do it. It might be able to, I don't know. Every day you've got 2 challenges. This is a fantastic way to show off your skills. Often these are used in interviews. This is a really good way to practice your computational logic skills. The interface is deliberately not very pretty. There's nothing to run your code on the website, so you can do this in any programming language. Everybody has different test data, but you just got to put your own answer in, and I love it. I think it's great. All right, thanks for your hard work. Let me know if you've got any questions.